Let us start sixth lesson, that is triangle. So last year we have learned, in 9th standard we have learned triangle. In that one we have discussed congruence of triangle. What do you mean by congruent figures? That means a figure that shape and size should be equal. And we have learned different theorems how to prove that congruency between two figures, by SAS, SSS, RHS, like that. So many theorems also we have learned last year. Here we are discussing in this chapter similarity of the figures. Similarity means figure should be the same shape, but size can be different. That is, if you are discussing about a equilateral triangle, another should be an equilateral triangle, and size can be different. Size, we know equilateral triangle, all three sides are equal, so sides should be in proportion and angles should be equal. So such figures, about that one we are going to discuss. So when you are taking the page number 118, similar figures, see two first figure, circles are given different circles of different radii. First one, concentric circles are given, that is circle with same center but different radii. Then two other circles, they are similar, that is shape a circle but size is different. Second one also, a square is given, square, size is different, so it is also similar, not congruent. Congruent means say shape and size should be same. Then another one, a triangle. So triangle, angles are same but sizes are different. Then next one, as a trapezium, there also size is different. Now look at that figure 6.3. So a photo of Taj Mahal it is given. So three different sizes. So it is taken in rectangular. So it is similar figure, that is shape is rectangle but size is different. So this two are called, how can you define similarity? That is, their corresponding angles should be equal and their corresponding sides are in the same ratio or in proportion. So if it is same ratio, that means if it is 1/2, another should be in the same ratio 1/2 or 2/3, like that. Whatever the ratio is, it should follow. Now see this one, figure 6.5. So two quadrilaterals are given. So one angle 85, another one 105, 100 and 70. Both angles are same. Now when you look at that sides, one is 2.1, then 1.5, 2.5, then 2.4, but the other one is 4.2, 3 and 5 and 4.8. So when you are taking the ratio 2.1 by 4.2, so it is 1/2 ratio. Again 1.5 by 3, that is again 1/2. 2.5 by 5, 1/2. And 2.4 by 4.8, again 1/2. So ratio also it is maintained and angles are equal. So such figures we can say they are similar figures. Now look at that square given, that is one square, that is 3 centimeter one side, and all the angles are 90 degree. Another one is a rectangle 3.5 and 3 is the breadth. So are they similar figures? Angles are same, all the 4 angles are 90 degree, but the sides are not in proportion. First figure, when you are taking, all sides are 3, so 3 by 3 1 you will get, again 3 by 3 1 you will get, but another one length when you are taking 3 by 3.5, so it is not in the same ratio. So here when you are taking a square and a rectangle, they are not similar figures, so that shape is not same. So angles and size should be equal. Now 6.7, you see, one square is given, another one is a rhombus. Here also sides you will get in ratio, that is 2.1 by 4.2, 1 by 2 ratio you will get, but angles are not equal. So we have there are two conditions for a polygons to be similar. That is, first one is that angles should be equal and sides should be in proportion. Both the condition, if it satisfy this both the condition, then only we can say two figures are similar. Okay, now let us discuss that 6.1 exercise. Fill in the blanks using the correct word given in the bracket. All circles are similar. No, all circles are similar. You cannot say congruent. Why? Because if the radius is equal, then only we can say they are congruent. So all circles when you are taking, that all circles are similar. Okay. Second one, all squares are again similar. Okay, not congruent. All squares means if it is smaller and another one is bigger, they won't be congruent. So all squares when you are taking, the option is similar. Then all dash triangles are similar. So in that one it will come equilateral triangle. Equilateral triangle, why we are taking equilateral triangle? Because in equilateral triangle all sides should be equal and all angles will be equal. So angle 60 60 60 you will get. So another equilateral triangle when you are taking, again angle will be 60 60 like that. Then sides should be always in proportion. So better option is equilateral triangle. Then fourth one, two polygons of the same number of sides are similar if first one, their corresponding angles are equal and their corresponding sides are proportional. So that is what we have learned now. Now give two different examples of a pair of similar figures and non-similar figures. For similar figures, you can give two circles, that is two circles, one of radius 5, another one of 6, so it will be similar. Otherwise, you draw a square of 4 centimeter and draw another square of 5 centimeter, 6 centimeter, like that. So it will be similar. Then non-similar figures, you can draw one a square, another one a rectangle. It will be non-similar. Then we have discussed here in this example, one is a square, another one is rhombus, that also non-similar. Then third one, state whether the following quadrilaterals are similar or not. So first one, a rhombus. Second one, a square. Seeing that, you can clearly say, no need to find out anything. Shape is not same. One is a square, another one is a rhombus. So it is not similar figure. If you want to give the explanation, you can give that angles are not equal. For the square, angles are 90 degree, but for rhombus it is different. So that two figures will not be similar. Now the case of similarity in the triangles. So when we are taking two triangles, their corresponding angles are equal and their corresponding sides are in the same ratio. So when we learn that congruence, we have learned corresponding, that is which one is equal to which angle is equal to which angle, that is sides which are equal, that we have learned last year. So corresponding angles should be equal and corresponding sides should be in the ratio. Okay, now theorem 6.1, if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Last year we have learned midpoint theorem. I hope you remember that. What was that? If a triangle is there, if a triangle is there, if a line passes through the midpoint of one of the side, and if it is parallel to the third side, it will pass through the midpoint of the second side. Okay, so I hope you remember that midpoint theorem. Okay, what was that? If a line passing through the midpoint of one of the side and parallel to the next side, it will pass through the midpoint of the third side, and reverse also it is true. That is, if there is a line parallel to this one and passing through if a line is there, then it was passing through the midpoints of two sides, it will be parallel to the third side. That also we have learnt midpoint theorem. And here basic proportionality theorem, that is we have to learn. That is, here if a line, no need to learn the proof, if a line drawn parallel to one side of the triangle intersect the other two sides at two distinct points, then the other two sides are divided in the ratio. A line should be there, a line parallel to this side, so it will divide the other two sides in the ratio. That means, suppose A, B, C are there, P and Q are there, so AP by BP will be equal to AQ by QC. That is the theorem. Okay, so one triangle is there and another line parallel to third side, it will be the it will divide the triangle in the same ratio. That is basic proportionality theorem. You have to remember that to solve the problems. The next theorem of the converse, that is, if a line divides any two sides of a triangle in the same ratio, then that line will be parallel to the third side. If suppose a line is there that divides the two sides in some ratio, that PQ will be parallel to BC. That is theorem says. Now exercise 6.2 given in figure 6.17 1 and 2, D is parallel to BC and EC in 1 and AD. You have to find EC and AD in second one. So let us draw that one. Exercise 6.2, first one. So 1.5, then 3, then 1, then this one you are asked to find out. So here D and E is given. So it is given D is parallel to BC. So we have just learned a theorem that says that if there is a line parallel to this line, so it will divide this in certain ratio. So you can take, as per the theorem, AD by DB will be equal to AE by EC. So AD, that is 1.5 by 3, will be equal to 1 by EC, or EC will be equal to 1.5 1.5 by 3 when you are taking, that will be 1 by 2, or EC will be equal to that 2 centimeter. Okay, EC will be equal to 2 centimeter. Now second one, a figure, one triangle, that D, again D is given, D, AD you are asked to find out, A, B, C, 1.8 and 5.4. Now AD by BD will be equal to AE by EC. So AD we have to find out. AD by 7.2 is equal to 1.8 by 5.4. 1.8 by 5.4, that is 1 by 3. So AD will be equal to 7.2 by 3. So it will be 2.4. So 2.4 centimeter. Now next problems are not included. Then let us discuss criteria for similarity of triangle. Theorems you are not supposed to learn, but you have to know the theorem. You have to prove, you don't have to learn, just learn the theorems. Okay, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence two triangles are similar. So for two triangles to be similar, two conditions it should follow. What are they? Their corresponding angles must be equal and sides should be in same ratio. Okay, then theorem 6.4, if in two triangles sides of one triangle are proportional the sides of other two triangle, then their corresponding angles are equal, then hence the two triangles are similar. So one triangle equal to the sides are proportional, then we can say two triangles are similar. Okay, that is Sss Similarity Theorem. Okay, so last year in congruence also we have learned Sss congruence, same Sss similarity, that is three sides should be proportional to three sides of another triangle. Then next one, 6.5, if one angle of a triangle is equal to one angle of the other triangle and sides including that angles is proportional, then we can say triangles are similar. So like SAS we have discussed. SAS means what? Side angle, side, that angle should be included angle in between that two sides. So suppose we are taking ABC, so included angle of AB and BC is B, like that. If two sides and included angle, so two sides should be proportional, angle should be equal. So if it is like that, by SAS proportionality theorem, SAS similarity theorem, that two triangles will be similar. Now example 7 we can discuss.